Hello, everybody. In Module 3, I discuss models of agency problems. Module 3 has 6 lessons. Today, we're focusing on Lesson 1. I'm going to provide a broad, general insights of agency models, in particular, moral hazard models. First, let's connect to the previous 2 modules. In the previous 2 modules, the focus is on capital markets. What kind of information can be inferred from prices in the capital market, and how investors and managers use information inferred from prices to make real decisions. In Module 1, as in traditional microeconomic models, everybody tries to maximize their own utility function. In Module 2, the feedback module, there is no inherent conflict of interest. The manager uses whatever information inferred from prices to maximize firm value. There is no conflict of interest between the manager and the shareholders. In this module, we're going to introduce conflict of interest between different parties. So, for example, managers and shareholders' preferences are not going to be aligned. This conflict of interest, together with frictions in the economy, is going to generate the so-called agency problems. There are 2 types of frictions that we're going to focus on. The first is unobservable action. The second is unobservable information. First, look at unobservable action. Unobservable action means that I privately take some action. That's why it's unobservable. That benefits me, but at the expense of you. Think about I as the CEO of the company and you as the shareholders of the company. I can privately take some action to benefit me. For example, I can use your money not to invest in the company, invest in operations, but let's say build a posh office or buy a fancy corporate jet. This is what we call the moral hazard problems. The second type of friction is the unobservable information. So I privately know some information that I can use to take advantage of you. For example, if I'm a used car dealer, I know this used car has a lot of issues, but I can still claim that the used car is like new. So I can trick you into buying this used car with a lot of issues by paying close to the price of a new car. And this is what we call the adverse selection problems. In this module, in contrast to the previous 2 modules, when we focus on capital markets, the main focus here is how we design contract to resolve those frictions. So a contracting solution for the conflict of interest issues. We're going to see we're not going to completely resolve the frictions. We're only going to partially resolve the frictions. So we want to make sure that the contracts make it incentive compatible to choose the desired action and review truthfully the private information. So I cannot observe your action, but I can make it incentive compatible for you to do the action I would prefer. I cannot observe your private information, but I can make it incentive compatible for you to review the private information truthfully. And so those incentive compatibility issues would generate distortions from first best. First best is defined by such frictions are absent. That's why we're saying contracting solution cannot completely resolve the frictions. So let's now look at moral hazard models and discuss the general insight of moral hazard models. In those models, there's a principal and an agent. The principal is going to delegate the execution of some task to the agent because the principal cannot do the task itself. For example, you can think about principal as shareholders of the firm and the agent is the manager of the firm. The principal cannot manage the firm by themselves. So the principal find a manager and delegate the management of the firm to the agent. There are a lot of actions that the agent can take that is not observable to the principal. The performance of the task, in this case, the underlying cash flow of the firm, the performance of the firm depends on the agent's efforts. And this agent effort is unobservable to the principal. You can't really monitor managers to see for 24 hours of every day how many hours the manager is spending on working on what. However, the task performance is observed. In a firm example, the firm's cash flows, the firm's earnings, the firm's stock performance, those are all observed. And of course, as we mentioned, there's conflict of interest between the principal and the agent. If the agent exerts more efforts, the firm performance is going to be higher expectation because there are still going to be some randomness. For example, if the macroeconomic is not in good situation, even if the agent exerts a lot of effort, firm performance may not necessarily be good. However, exerting effort is costly to the agents. The principal, they care about the performance of the task. They don't care about the agent's effort per se, but they do understand that they need to induce the agent to exert efforts, and exerting effort is costly to the agents. Here, the conflict of interest. So what the principal is going to do, the principal is going to design a contract because effort is not observable. The contract can only be based on observable outcome, induce the agent to carry out whatever action the principal prefers. The first question is, does unobservable effort always generate distortion? The answer is no. There are various cases when action being unobservable does not generate a distortion. The first case is when the outcome is a deterministic function of the effort. So for example, if A is effort, the outcome, let's say, is A plus 2. In this case, observing X is equivalent to observing A because you just subtract 2 from X, you get A. In this case, you can observe action. There is no moral hazard issue. The second case is when the outcome is a stochastic function of the effort. However, the possible outcome of the distribution varies with effort. So here is an example. You think about outcome when exerting high effort is distributed between 10 and 100. And when exerting low effort, it's distributed between 0 and 9. And suppose the principal prefers high effort. In this case, the principal is going to set infinitely large penalty when observing outcome between 0 and 9. Because in this case, it's perfectly indicative that the agent exerts low effort. In this case, the agent is going to be forced to induce high efforts because otherwise the agent is going to incur infinitely large penalty. Technically, this is what we call moving support condition. And if you have moving support, it does not generate distortion. The third case is when the agent is risk neutral. In this case, you can simply sell the task to the agent. In the shareholder manager example, it's like you're selling the firm to the agent. And in this case, the agent is going to bear all of the outcome risk because the agent is like the owner of the firm, bears all of the outcome risk. So the agent is going to exert the optimal effort level to maximize the expected value of the outcome minus the effort cost, which is equivalent to effort being observed, get to the first best. However, if those assumptions are violated, then there will be distortions. And here's the basic intuition of the distortion. As a principal, I want the agent to exert high effort. And I know that higher effort is more likely to generate higher outcome. So what I'm going to do, I'm going to reward the agent for higher outcome by paying the agent a higher amount. Now, I'm going to penalize the agent for lower outcome by paying the agent lower payments. In this case, the agent is going to bear a lot of risk with respect to the payment because the agent's payment is going to fluctuate with outcome, which is random, even when the agent exerts efforts. And if the agent is more risk averse than the principal, then there is distortion because of suboptimal risk sharing. If the agent is more risk averse than the principal, then it is the principal rather than the agent should bear more risk. If in an extreme case, the principal is risk neutral and the agent is risk averse, then the principal should bear all the risk and the agent should bear none of the risk. That means the principal should pay the agent a fixed wage. But paying the agent a fixed wage, then the agent is not going to exert effort because exerting effort is costly and you get the same payment. So this is distortion due to suboptimal risk sharing that we're talking about. Later, we're going to talk about if the principal and agent are risk neutral, but the agent has limited liability, you're going to generate distortion, which is intuitively similar but it's of a different form. And so the basic moral hazards focus on single task and single action. You have one action and it affects the performance of one task. If you extend that to multitask models with multiple actions, those kind of models, they could explain why contracts that we observe in practice often use fixed wages. Because based on the single task, single action model we just talked about, you cannot offer fixed wages, because if you offer fixed wages, the agent is not going to work. Or equivalently, what we're saying is the incentive you offer to the agent is not large enough. And here is the intuition. If you have multitasks, then it is possible that the outcome of some task is easier to measure than the others. In this case, if you provide incentives, if your wage payment varies with the outcome of the tasks, the agent is going to provide a lot of effort on the task whose outcome is easier to measure. And then for the other tasks, the agent is not going to exert sufficient expense, whereas the other tasks are equally important to you. One example is if you're a teacher, you teach students, standard test scores are easier to measure, whereas learning experience is difficult to measure. So if you offer contracts that pays teachers solely on standard test scores, the teachers would put a lot of effort in teaching students how to prepare for the standard tests, but ignoring other parts of their education, which may be equally important or even more important. So in this case, it might be optimal to use fixed wage. In this case, you can make sure that agent does not exert too much effort on those easier to measure outcome tasks. If you want more details, check Holmstrom and Milgram 1991 Journal of Law, Economics, and Organization paper. We're not going to cover this in this module. What happens if there's one principal and multiple agents with a single task? If you consider such a setting, it generates two additional insights. First, if there is a single output, and the single output depends on the effort level of all the team members, then there will be free rider problems. Because if you exert efforts, the task performance improves, you're only going to get a fraction of the share of the increased output, but you're bearing your effort cost. So this free rider problem results in members not willing to exert enough effort. How can this issue be resolved? What you can do is you can impose a sufficiently large team penalty if the output is lower than some threshold. Basically means that if the output is lower than some threshold, then everybody is going to be subject to the penalty. Everybody is going to see their payment gets cut. But here's the intuition. Intuition is if you have a team penalty, then if the agent exerts less efforts, then the whole team, including the agent itself, is penalized. The agent may not care about the team members being penalized, but the agent surely cares about itself being penalized. So in this case, the agent is going to exert effort. The second insight is that if each agent produces some output that depend on each one's effort, then we can use relative performance contracts, induce the agents to work harder by pitting one against the other. So that justifies the use of relative performance evaluation, RPE, to filter out some common noise and induce each agent to exert high efforts. Because if you can filter out common noise, that means your contract becomes less risky. So it imposes less risk on the agent and it improves the risk share. And so this is the justification of the common use of relative performance evaluation in contracts. And again, we're not going to discuss this in detail in this module. But if you're interested in more details on this issue, check Holmstrom 1982, the Bell Journal of Economics paper. So to conclude, moral hazards refers to the friction in the economy of effort being unobserved. This effort is going to benefit the principal, at least in expectation, but it's costly to the agents. So there's a conflict of interest between the principal and the agents. Combined with the friction and unobservable effort, it generates agency problems. And you need to provide incentive for the agent to exert the effort that the principal prefers. And the moral hazards generates distortions from the first best, because if you want to provide enough effort incentives, you want a variation in wages paid to the agents. But such variation is going to be costly. It's going to deviate from optimal risk sharing because the agent is more risk averse. So there is this trade-off. In the next lesson, we're going to use a simple model to illustrate these insights from a basic moral hazard model. If you want to check your understanding of this lesson, you can take the quiz at the link found on the slides. Thank you very much.